Hey, MathKook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at MathKook.com. Let's MathKook it up. This question says, change the quantity a cubed b c to the fourth, all raised to the 1/2, to radical form and simplify if possible. So let's go ahead and write out our original expression here. So we have a to the third, b, c to the fourth, to the 1/2. So how do we write this here in radical form? So let's look at how to do that. Right now, this expression is in exponential form. So we are going to change this to radical form. Now notice we have a 1/2 here. So the 1, or the a, is going to stay with the base here as the exponent. The denominator, or b, in this case 2, will become the root. So let's go ahead and change that. So because the denominator is 2, we have a square root. We have a cubed b c to the fourth. Now that's all raised to the first power, but the first power in this case doesn't mean much because if you distribute the 4 to all these exponents, it just stays the same. So for simplicity, I'm going to go ahead and get rid of that and then just write a cubed b and then c to the fourth. And remember, our root here is a 2. So I'll write that 2 there. So we have a square root of this quantity. So let's see if we can take anything out. So 2 goes into 3 how many times? It goes in once. So that means we can take out 1a, and there will be an a left underneath the radical. Now, does 2 go into 1 here for the b? No, so that b will stay underneath the radical. And then lastly, does 2 go into the 4 here for c? Yeah, 2 goes into 4 twice, and there's no c's remaining. So 2 goes into 4 twice, so we'll have a c squared out front. And then what's left underneath the radical? Well, remember we had an a left over because 2 went to 3 once, but there's 1 remaining. So we have an a here, and then this b never came out of the radical to begin with, so it stays underneath the radical. So now, whenever we take out variables out of an even root, if that variable has an odd exponent, we have to put absolute values around it. So in this case, we have an a to the first power here, and we had an even root. So this a needs absolute values around it. So there is our answer. And notice the c is squared, so that c does not need absolute values around it because it has an even exponent. Alright, so let's go ahead and box our answer. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit MathKook.com. Thanks for watching.